Hi and Assalamualaikum. My name is Mohamad Zahid bin Hamzah. My matrix ID is AD180080. My group members and I will present to you our topic, which is the metal forming handling in rolling and deep drawing. For the introduction, the metal forming handling is the form most common prepare which is utilized to deliver the basic parts and its components that have been utilized broadly in a part of businesses such as in vehicle, aviation, and machines. The metal shaping handle has the operations of which the deformation of sheet or a tube metal to form a certain component that features a certain mounted geometry. In this ponder, it is critical to know the fabric conduct in metal forming, the reasonable temperature required for the metal shaping, and the association of grinding and lubrication within the metal forming. The impact of temperature is additionally playing an imperative part within the sheet metal shaping handle. The proper temperature must be recognized sometime recently, carrying out the test of an example or certain metal shaping prepare. In common, strain solidifying and quality will be diminished due to utilization of higher temperatures. The metal forming can work at temperature ranges, which is cold, warm, and hot working. To decrease the destructive impact of grinding of the metalworking of oils will be utilized as a toolwork interface in most of the shaping operations. By having the lubricants, it will create distant improve surface wrap of manufacturing. Next is material conduct and its improvements in metal forming. For example, in the car industry, the usage of lightweight designs concept is to play down the utilize of destructive outflows and to make economical cars and to the lawful prerequisite within the arrangement handle. The plan rule can be connected as the fabric connected is high quality and high solidness. By considering these two properties, the metal forming ought to be comprising of high quality steels, light metals, and combinations such as aluminium and magnesium. From the discoveries, there's a non-stop stream of steel advancements forward to a few presentation of modern progress steel materials within the final 6 years, as shown in the diagram below, in the figure below. Now I will show you the influence of temperature in metal forming. For metal forming manufacturing in general, the temperature gradient between the die and the work has a large effect on the metal flow during the process. The metal nearer to the die surfaces will be cooler than the metal closer to the inside of the part, and cooler metal does not flow easily. As shown in the diagram below, this is the stress over strain diagram for metals, which the tensile strength will rise and then fluctuates after reaching the max point. Next, the strain rate sensitivity effects. In metal forming processes, the behavior of the metal undergoing large plastic deformation is affected by the dynamic or strain rate effects of the material and inertia effect. They are effectively treated by the finite element methods, which can take account of strain rate effect. Usually, the effect of strain rate on the flow stress of metals is not significant at low temperature and becomes significant as the temperature rises. When the strain rate effect is significant, the forming pressure is lowered by decreasing the strain rate. The deformed shape of the material is also affected by strain rate effect. Now I will show you the friction and lubrication effects. For the friction effects, forming loads and stresses transfers to die depends on friction and reduced by lubrication. The surface quality of formed workpiece depends on friction and lubricant used. Wear of die can be reduced if lubricant films are applied, which reduces friction. For the next one is lubrication effects. Lubrication is vitally important in many bulk metals forming process. In most cases, reduction of friction has a beneficial effect by lowering the forces required for a given operation. This reduces the stresses imposed on the tooling and may allow the use of smaller and less costly equipment. Last one from me is frictional conduct in metal forming. The inclusion of lubricants is exceptionally significant within the sheet metal forming handle. Most of the forming operations apply low contact because it can diminish the weight of the tooling and to the shaping stack. Within the metal forming, lubricants moreover utilized as an apparatus to anticipate erosion as well as to ensure the shape and physical geometry of the workpiece and its middle. Other than that, the blank coating also impacts the grinding for the level confront grinding test. In any case, the impact of the clear coating is impacted by a diverse sort of fabricating handle. To test the wear test of the framework, commonly the ball on this test will be utilized as essential investigate of the contact and the wear happens. Band compression test is another short test to calculate the wear marvels such as irritating that shows up on metal shaping. There is moreover a strip drawing test were conducted to distinguish the wear that happens on the device surface. The avoidance of the grease will diminish the number of prepare steps in generation. It will moreover diminish the natural impacts and decrease the avoidable well-being burden. The complex challenges must be confronted amid the metal shaping, prepared by obeying the field of fabric science to realize the shirking that required. That's all from me. Thank you.
Assalamualaikum, my name is Mohamad bin Khairi and my metric number is AD180057, and I will continue the literature review. For this literature review, in this chapter, a survey of writing of various things about has been conducted for metal forming, which clarifies the nuts and bolts of sheet metal shaping, adaptability, formability, and progress-savvy device in metal forming. The methods such as bulk distortions in rolling, sheet metal workings in profound drawing, this is strip drawing, apart from the other. There's more to analyze the method, such as the angle of the method and the defects. For the 2.1 rolling process in metal forming. As we see in rolling, fogging and extrusions, so the characteristic of sheet metal as we see below is one by one. So the first is strength. As we see, the ability of material which can withhold the forces acting which does not break, gets deformed, or does not bend as well. So for the elongation, as we see, its main characteristic of sheet metal which can get stretched out without any fracture or failure. For the elasticity, as we see, this is ability of material here is absorb the forces acting and it gets stretched up in different direction and again returning to its original shapes. For the plasticity, as we see, it is ability of material when applying the forces on it and it does not return to its original shape. And conductivity, as we see, as ability to produce moving electron which is further produce electricity. For the tensile strength, the ability to get stretched up to a larger extent without breaking. For the grain size, when stretched, the sheet metal it's find the surface roughness. Ductility, it is its ability of material when upon stretching it changes its shapes. So the characteristic of this sheet metal is explained above. Definition of rolling process. Rolling is defined as a process to form metals where the metal strip is pressed by two or multiple rollers, thus the uniform thickness is formed. To do this, the temperature is essential. There are two types of processes. One is hot roll and another is cold roll. For the working principle of rolling process, I will explain a little bit of it. The rolling process is a metal forming process in which stock of the material is passed between one or more pairs of rollers in order to reduce and to maintain the uniform thickness. So the rolling process are mainly focused on the increasing length and the decreasing thickness without changing the width of the workpiece. So here types of rolling mills. There are 5 rolling mills which are commonly used for rolling metals. First is 2 height rolling mills, second 3 height rolling mills, third 4 height rolling mills, fourth tandem rolling mills, and fifth cluster rolling mills. For the first, there are two height rolling mills. So they have two types of this mill. Those are reversing mills in reversing mills. So for the two height rolling reversing mills, in this type of mill the roller are both adjustable. In this mill, rotation of the two rollers are made in two different directions. For the two height non-reversing mills, in this mill two rollers continuously revolve in the same direction, and we cannot reverse the direction of the rollers. In this operation, the motive power is less costly. Okay, second is three height rolling mills. In this mill, the three rolls stand in parallel one by others. The rolls are rotating in opposite direction. In this mill, between the first and the second rolls, the material passes. If the second roll rotates in a direction, then the bottom roll rotates in another direction. The material is rolled both in forward and return in three height rolling mills. For the third is four height rolling mills. In this type of mill, there are four parallel rolls one by another. In this operation, the rotation of the first and the fourth rolls take place in the opposite direction of the second and the third rolls. The second and the third rolls are smaller to provide rigidity in necessity, so those are known as backup rolls. It is used in the hot rolling process of the armor and in the cold rolling process of sheet strips and plates. The fourth is tandem rolling mills. In this type of rolling mill, there are two or more sets of rolls in the parallel alignment which make the continuous passes and successively decrease the thickness and make the uniform. And for the fifth, cluster rolling mills. In this type of rolling mill, there are two basic rolls that are backed up by two or more rolls which are bigger than those two basic rolls. This backup roll gives more pressure to the basic roll to heavily press the strip. So the application of rolling mills is the rolling operation used in various industries such as road. Seamless hollow tubes are made by rolling. Rolling is used to producing cross-section of larger section and used to cutting the gears on the gear blank. And the threaded part, bolt, screw, another example which have mass production is made by the rolling process. In automotive industry, various parts are manufactured by rolling process. The rolling process is used to make plates, steel and sheets. Bearing, turbine, rings are rolling products. 2.3 Deep drawing process in metal forming. Deep drawing is one of the most widely used processes in sheet metal forming. Apart from its use in many other sectors, it is applied in the automotive industry for the manufacturing of car body parts. So there are three types processes. First is deep drawing with tool, deep drawing with active means, and deep drawing with active energy. This is last from me. Summary of the literature review. In conclusion, profound drawing or deep drawing is the foremost common steel forming handle accessible to producers since it offers extraordinary shaping characteristic and solid aging resistance. It has checked the truth that the method is the foremost vital within the fabricating world forming stage. As for the rolling handle, the show article centered on rolling operation as a metal forming strategy in mechanical fabricating operation. And we are able to see various analysts put their assertion on how to deliver viable generation to maintain a strategic distance from defect or problem in rolling or profound drawing, as well as formability of the metal forming. We gather encompasses a way better understanding of the sort of abundant in rolling and deep drawing forms to meet expanded operational execution in future mechanical manufacturing. And that's all for me, and Mohd Iman will continue the other parts. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Iman Hafifi bin Mohd Nordin. My metric number is AD180202. So I would like to present about my project. First part is about methodology. The method of metal forming can be classified into many methods or special procedures to perform a certain yield prepare. For this paper, it is chosen that the method for metal shaping will be the rolling handle from the bulk distortion, and the profound drawing prepare will be from the sheet metal working prepare. As for the rolling prepare, it can be carried out by utilizing wedge rolling or adapter rolling. Whereas for the profound drawing, it can be prepared by utilizing the strategy of incremental, deep, and the small scale profound drawing. From doing feature investigate through the journals, it is additional found that there is a random handle that is utilized within the metal forming process. So second part is cross wedge rolling. In theoretical and experimental modeling, cross wedge rolling is the basic plastic forming process in the production of axial symmetric geometry. The rolling process is performed using wedge shaped tools. This technology allows one to obtain a product of high quality and accuracy. This method can be employed to manufacture semi-finished products later subjected to machining. Compared to other plastic working technologies used for manufacturing axial symmetric products, this method allows for obtaining 60% less material waste. So the next part is about inner crack in the rolling process are caused by the Mannesmann effect. The defects are usually longitudinal axial cracks. The factor influencing the occurrence of the Mannesmann effects are first, cyclically interchanging compressive and tensile stresses, and second, gradual damage of material cohesion resulting from low circle material fatigue. So in the investigation of the limits to the process of cross rolling, computer techniques 11, 12, 13, and to a smaller extent physically modeling. So in the material used for testing to fulfill the four main criteria of similarity towards the real material, in order for the simulation to be correct, it is necessary for the following aspect to be similar. Firstly, material flow curve for the model and real material. Secondly, friction condition. It is suggested that the values of both friction factor and coefficient thought to be the same for both material. Thirdly, shape of the tools. And lastly, forming kinematics of the investigate process. So the next part is result of experiment or analysis. Rolling temperature and rolling speed to cooperate with each other when under the condition of high temperature, and rolling to rolling speed regulation higher. When the rolling temperature is low, the rolling speed regulation of the low. Cross wedge rolling forming of aluminium alloy, the heating temperature at 300 until 350 Celsius Celsius. The heating temperature of mold in 150 until 200 degrees Celsius. In order to normal rolling aluminium alloy parts not on a molding surface adding agent. Although aluminium alloy material plasticity is good, but in the high temperature plastic, the formation of demolding is not easy. Namely, the workpiece surface and the mold surface prone to to adhesion, which lead the decline in the quality of workpiece surface. So, the next part is flexible rolling forming. Continuous roll forming (CRF) is a novel forming process for three-dimensional surface parts, in which a pair of bendable forming rolls is used as sheet metal forming tool. By controlling the gap between the upper and lower forming rolls, sheet metal is non-uniformly extended in the longitudinal direction while it is bent in the transverse direction during the rolling process. As a result, longitudinal bending is gained and a doubly curved surface is formed. With the rotation of the forming rolls, the sheet metal is deformed consecutively and a three-dimensional surface part is shaped continuously. So, the forming experiments on typical surface parts and measured results shows that forming result with good precision can be obtained by CRF process. The next part is in theoretical or experimental modeling. Flexible rolling is a relatively new technology. Its objective is to produce sheet material for components which will be subjected to loads and stresses that vary with location. By controlling the roll gap during the pass, the product thus created possesses a varying wall thickness. Thick where the loading is heavy, thin where it's not. As a direct competition to tailor welded blanks, the material discontinuity is removed. After a brief review of the background, the result of a set of experiments on flexible rolling are presented. And the next part is incremental sheet forming (ISF). In theoretical or experimental modeling, incremental forming process is a flexible and versatile process with a promising future in batch manufacturing and prototyping sectors. Traditional sheet metal forming processes usually involve high costs due to the design and manufacturing process involved in it. Moreover, the design of die is unique for every individual component. The contemporary sheet metal industry employs forming methods which uses precise punch and dies to form components with precise tolerance. In mass production, the high cost involved in the manufacture of dies and punch absorbed by the number of components formed, whereas this is not the case for low volume production, which increases the manufacturing cost of product in low volume production. To solve this incremental forming process, a rapid sheet metal forming process has been introduced, and it is under research for a couple of decades. The next part is experimental setup or component setup. Many researchers are working in the field of ISF. Malhotra et al. 2012 found that the nature of the formation is local and is primarily responsible for increased formability in SPIF. That bending plays a significant role in ISF deformation stability. So, the Atanasio 2008 optimized the tool parts in 2-point sheet incremental forming with the full die to reproduce an automotive component with best dimensional accuracy. The main elements of the incremental sheet hydroforming machine are identified as: first, sheet metal blank; second, hydraulic blank holder; third, ball point forming tool or deforming tool; fourth, CNC machine; and lastly, hydraulic system. So, thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hello everybody. Today I would like to present about our group project, which is entitled the metal forming, handling in rolling and profile drawing. So I would like to continue our part for this group project. Firstly, I want to explain about micro deep drawing, theoretical and experimental modeling. So we know micro deep drawing, short form MDD process, is a fundamental microforming method with potential application in forming of cups, hollows, and boxes, and has an edge over other micro manufacturing methods. There are numerous process parameters and other factors that affect product quality produced by deep drawing. So this paper is highlighting recent research work and result in deep drawing. The deep drawing operation performed to produce light weight, high strength, low density, and corrosion resistable product. So that we use the deep drawing operation because they have a great characteristic and also their benefits. So at here we can look this about micro deep drawing. So next we go to the experimental setup and component setup. Sheet metal forming process are technologically among the most important metalworking processes. Products made by sheet forming process include a very large variety of different geometrical shape and size, like simple bend to double curvature, even with deep recesses and intricate shape. So we can see here about the experimental setup and also the component setup. This is about the machine and also the other component. Next we're going to the other parts, which is about the miscellaneous theoretical and experimental modeling. Metal spinning, also called conventional spinning or just spinning, is the forming of an axis symmetry part over a rotating mandrel. Force is delivered by a tool with a rounded end of a roller. A flat or possibly perform workpiece is held between a mandrel and a tail stalk. As the apparatus rotates, the tool applies localized pressure of the work while it gradually moves up the mandrel. This causes the sheet metal work to be wrapped over the mandrel, thus taking its shape. Metal spinning is commonly performed cool, but in some cases, parts may be subject to warm or hot spinning. So spinning is capable of producing large parts, which diameter as high as 20 feet. So, by the experimental design, the tooling in the metal spinning operation is generally made from tool steel. So, the mandrel in some cases may be made of wood. Containers with bottle or tapered net can be manufactured on collapsible mandrel that are disassembled and removed from the form parts. Setup cost from metal spinning, I think, is usually low. So I think it's a great to set up the design because one of the factor is the low cost. So next we can see that about the sheet metal spinning. So here they have shear spinning. Shear spinning is process related to conventional spinning and is also known as floor turning or spin forging. So in tube spinning is performed on cylindrical parts. Tube spinning is similar to shear spinning in that metal flow occurs within the wood. So here is about the experimental setup and component setup. So for the result of experiment, the analysis by Hartel and Avises show that higher initial sheet diameter and lower operating angle increase wrinkling and thinning. However, a higher roller feed rate leads to produce thinning and increase the wrinkling. So yeah, about the component, tripod component, cone component. So as the conclusion, the results show that the product of the cross wedge rolling process can be affected by a cross-section reduction, wedge and shoulder angle because it can lead to a change in displacement of the joining zone. It also shows that forming velocity does not affect the displacement. So yeah, that about our conclusion. I think that's all from me for our part. Thank you for this time.